So this section is, for some reason, like the longest that I've ever done. Just this is my third video on it, but I feel like this index feature is pretty important for you to understand how this works. Now, one of the things I do want to make sure you understand is that, because I don't think it comes up until later, is we basically have two operations we can do with these brackets. The first one we've been seeing is just retrieval, right? Also known in the computer science word as get. They're often called accessors and mutators, but everybody just calls getting and setting, or getters and setters. So you can get things from a list at a specific index by using the bracket notation, this subscript notation over here with an index. Okay, and it's really cool that another feature we can. Now, it's important to actually, before I move on, it's important to understand that, again, we're dealing with variables that aren't completely linked over here. So if I say fruit is equal to bread, okay, right, it's going to print out bread. But if I print out shopping over here, we notice that declare shopping, we create fruit, fruit is equal to bread, we print out shopping, and the shopping list hasn't changed. Now, what's gone on over here, right? And I think this is worth drawing out for you guys, is if we go back over here, and let's go ahead and clear this canvas, right? So this was, we have a shopping list. We have our shopping list over here. Let's go ahead and draw this. Okay. Oops, shopping list. Okay, and 1, 2, 3, 4. And so apple, banana, etc, etc, because it's not really relevant. Right, this is what's stored inside of shopping. Let's go ahead and use a different color to represent the variable. Shopping. Okay, similarly, we have another variable called fruit. Okay? And so when we execute so the first line we did created this list: apple, banana, cucumber, durian. Don't need to bother writing this out. The second line was fruit is equal to shopping 1, which retrieved banana out of it, right? Retrieved banana out of it and replaced it in this expression, right? The shopping 1 expression evaluated to banana. So now fruit stores the word banana. Now remember, when we say fruit, so now when we do this next line where we execute this line, fruit is equal to bread, what this line is doing is, remember, this is the assignment operator, right? Take the expression that's been stored, that's been evaluated in the right, and store it in the variable on the left, right? Remember, it's not setting up this hard binding. It is saying, take this and store it in here. So now, essentially the fruit, if we were to ask fruit what it refers to, after we execute that line, fruit is going to basically, instead of referring us to banana, it's going to say bread. Although that is a false fact. It is not fruit unless it's maybe banana bread, and I'm not sure if we can count. We can count that as a fruit if you're being generous. It's that kind of year, you know. So that's hard bind. So basically, remember, these two things are kind of just joint. And I will show an example called aliasing, where they're not, but it's very specific. Okay, so how do I? So that leads to the question: how do I actually change what's inside of here? So we can change what's inside of shopping by using the same bracket notation, just putting the bracket on the other side. Not breading. Shopping. 1 is equal to bread. And now if we run these, we see that we have our 3 lines: shopping, bread, print shopping. And this will replace banana. It's going to store it in index 1. One useful way to view this is that each of the individual boxes that we are creating over here is actually a variable. It is a variable just like the it's a variable just like anything else is, except it's shopping 0, shopping 1, shopping 2, shopping 3. Okay, so that's important. Similar now, what's the other? But this is for lists. Lists are mutable. They can be changed, and I've mentioned this, but strings are immutable and tuples are immutable. So we rarely use tuples, but all you have to understand is that they're that about tuples is that they are lists that are immutable. So if I try to do this if I try to do this, tuple does not support item assignment, right? Line 14, it gives me that error, right? All I did was change this from a list to a tuple. So that, again, is the only real difference we really care about with lists and tuples, and why we rarely use tuples anyway, because they're the same as lists, you just can't change them, which is useful in some cases when you don't want to change things specifically. Okay. Now, the final note we want to make about this is that if we try to, let's go back up over here. Python, if I try to turn it into Cython by adding a C in the end, adding a C to the beginning instead of a P. So word index 0 is equal to, and let's just do that over here. Word at index 0 is equal to C. String object does not support object assignment as item assignment as well. So you can see over there that we are not allowed to basically change what's put into a word, or we cannot change the individual letters in a word like that. Right? We're not allowed to do that. What we can do, of course, is we can indeed store things in a variable. So I can do this. So I can do letter is equal to word at index 2, print letter, and let's just run only these things. I only just learned about it just by accident, and it's so useful. So, boom, T. Now, the final case is what if we, as I mentioned, there is something called that where basically changing one variable can change another variable. So let's take a look at shopping alias. So this is a feature in most programming languages, and it works exactly the way you'd expect. Shopping alias is equal to shopping. So let's go ahead and do shopping alias. 1 is equal to bread, print shopping, and let's go ahead and run it. And notice that by changing shopping alias, we change shopping. Now why is that? Because when we created that variable shopping alias, we aren't copying this entire thing because copying lists is expensive. Instead, we have a variable now called shopping alias, and that also points to this list. So this line over here, this is the reach example I was talking about last video. This variable over here basically points to the same thing as this. It's an alias for it. So changing this does change that because they are the same list. They are referring to the same thing. They have the memory location of the same list stored in them. So changing the thing they are pointing to, not changing what is stored in them, but changing the thing that they point to does have an effect. All right, we'll learn more about that in detail, so don't worry about it too much right now, because you'll notice that that's not really gone into the book, nor is the setting stuff, but this was the appropriate place to bring it up. So the next video should go by pretty darn quick.